board. Off we go. And so I want to take a look at set number 1 here, where I'm given these stages to play with, and I got to figure out what's the pattern. So the first thing to do is write something down on paper about it. If you just try to look at these and then start typing in the boxes without anything on paper, you're doing yourself a disservice, so please write math down. Okay, so let's screenshot that into my whiteboard over here. Shot. And again, I have this fancy whiteboard. Otherwise, you would have to copy that onto your paper. So this is lesson 3.1, part 1. And I'm going to right away turn this into a table like the one shown in the problem, where I have the stage number 1, 2, 3, 4, and so on, versus the number of circles or dots, whatever you want to call them. And let's see my screen. Can you all see my screen? Just want to confirm.
Yes.
Okay, cool. Thank you. So I have, let's see, 1, 2, 3, 4 dots around and 1 in the middle. So there's 5 there. And then kind of building off this one right here, I have the 1, then 4, then another 4. So that's going to give me 9. And then it looks like we're building on that previous image. And again, we all see different things when we look at this stuff. I have the previous image plus another 4. So it looks like I'm adding 4 from stage to stage. Okay, so I could draw the next picture, but I think I'm going to choose not to. So what's 9 plus 4 on a good day? That's 13. Yeah. So the next one would have 17. And I could keep going if I wanted to. Ultimately, what I want is in n, which means find a formula where n could be any of these numbers. Okay. So n is any stage. So I have to write a formula. Based on our experience formula, there we go. In the last couple of classes, I think we talked about a discovery that if you repeatedly add, that's a multiplication. So these repeated 4s, repeated 4 implies multiplication. So my formula has to be something like 4n. Now these numbers are all odd, so that means I have to add or subtract some number to adjust it. Okay, so I'm just going to check on that. Now, I just got hit by an intuition that might be helpful. There's always 4 extra around the outside and 1 in the middle. So I'm thinking maybe, I'm just going to throw a guess at this, it might be 4n plus 1. I'm not sure. That's a question. I have to check it. So you make a guess is the way I like to do these, and then check by picking a number for n, like n equals 3. Okay. For n equals 3, I should get 13 as the answer. So if I plug in 3 into my formula, 4 times 3 is 12, 12 plus 1 is 13. And hey, that's the right answer. So I got lucky by that observation here. Do I always get lucky? The answer is no. Sometimes I mess around and get it wrong several times before I get it right. And that's kind of the essence of math. It's a subject where you struggle, get things wrong, and finally it's like, oh, duh, right, there it is. Okay, so I think I have a formula. I'm just going to check it again just to make sure, because sometimes I'm full of it. So let's try n equals 2 just to see. So 4, plug in n equals 2 plus 1. 8 plus 1 is 9, and that does check. Okay, so I did find a formula after a little bit of educated guessing, and I'm ready to go back from my notebook to my problem and start typing stuff in. So 1 was 5, 2, oh, another thing, just a reminder, whenever you click on a box, it gives you information. In this case, it says enter an integer or a decimal. And if you click more, it will give you examples of the kinds of things you can type. So keep that in mind. Let me see, what was it? 4, 9, 13, 17. And this one's going to be, I think, what, 41, if I got that right. And then what's the formula for n? I believe that's 4. And I could either just type 4n plus 1, or I could put a times in between with the asterisk on the keyboard. And then how many dots will be in the 20th stage? And so maybe I need a calculator. Maybe I can do that in my head. Let's see, 4 times 20 is 80, so that'd be 81. But it'd be a good idea to check. If this is a test, I'm definitely writing that on paper and I'm checking. How many, what stage will be 137 dots? Ooh, man, I don't know. Can somebody help me out? What am I gonna do about that? They didn't tell me what n was. I gotta guess what n is? What should I do?
Subtract 1 and then divide.
Yeah, so we're gonna undo the formula. So we're gonna solve an equation for 137. So new page. Yeah, so the formula says if I knew n, I would multiply by 4 and then add 1. So if I don't know n, I have to undo that. So that's basically saying, hey, I want the answer to be 137. So I'm going to solve this by subtracting 1. That's going to give me 136. 1 minus 1 is 0. 0 plus 4n is 4n. And then I can divide by 4 on both sides. And let's see, 4 goes into 13 3 times with 1 left over. 4 goes into 16 4 times. I think the answer is 34. I'm going to check just to make sure. 4 times 34 plus 1 on a calculator. 4 times 34 plus 1. So you can just, in a Google search engine, you can just type some calculation and it will whip out a calculator with the answer. Okay, so I checked, yep, I get 137 dots in the 34th figure, so I got it. And what kind of pattern is this? Linear, quadratic? Anyone?
Linear.
Linear, yeah. And it's linear because a couple ways to think about it. I'm adding the same number repeatedly, so that 4 is my slope. And if I were to try to plot these points right here, they would line up very nicely. Okay. And we'll do a plot question later. So this should be linear. And again, this is designed so you submit question parts one at a time. And if you get stuck on something, eventually you'll get shown the answer and you can try again. So let's just suppose I got that wrong. And it's not going to show me the answer yet. Maybe I'm going to guess 82. Oh, let's try 83. So eventually it shows me the answer with a little explanation. Then I can say, oh, okay, 81, and then submit it, and I'll at least get some credit. So on the lessons, you don't get full credit, but on the homework and the prep, you do. All right, so let's move along. What did I have on my list of fun things? Fun with a spreadsheet. Okay, let's do the squares next, and then we'll do fun with a spreadsheet. So that would be, let's see, question set 2. That's kind of like the one we just did. I'm going to skip that. Question set 3 is a little bit more challenging, and a bunch of you wrote to me about this problem. And I wrote back with some advice, and sometimes like you might get annoyed by my advice because I ask you questions. Because if I just give you the answer, then I'm afraid you might not learn as much as if you struggle with it a little bit. All right, so the important thing I wrote back to people on this one here is describe what you see to somebody who can't see it. So like stage 2, I might tell my mom, hey mom, I see 6 squares. And my mom says, oh, okay, you see this. that what I see? Answer is no. Okay, so how could I describe better to my mom so she knows what I see? Somebody want to give this one a shot? So my mom could draw what I see without having seen it herself. What would I tell her?
2 rows of vertical lines that include 3 squares.
Yeah, good. Okay. So I'm going to call them columns because they're vertical, but vertical rows works too. So 2 columns of 3 squares each. And I see the chat flashing. Let's see what we got there. Chat. Where are you? There you are. 2 columns of 3 squares. Nice. Okay, so we're right on this. And then I could do a similar description for stage 3. So I'm just going to kind of summarize that in a table and hope I see a pattern. So stage versus pattern. So I'm going to skip 1 for a minute, 2, and then 3. So 2 columns of 3. And then this one, wouldn't that then be 3 columns of 4? And then this one would just be 1 column of 2. And then, so what would the 4th one be?
4 columns of 5.
4 columns of 5. You guys rock. And then I see a pattern here, right? There's a pattern to those numbers there, and there's another pattern to these numbers here. And what I want to do is I kind of want to generalize that. So to put it in a formula with an n. So using n, I think I would say there are n columns, right? Because n is either a 4 or a 3 or a 2 or a 1. N is that first number, right? The number of columns matches the stage number. So we see n columns of, how do I write the next number? Using an n.
N plus 1.
N plus 1, you got it. Yeah, so the next number would be n plus 1. And then I can turn that, this is a rectangle, right? And a rectangle is base times height. So I get a formula out of that as n times n plus 1. So I think I have a formula. So I'm just going to double check that. With n equals 3, if I replace these n's with a 3, I get 3 times 3 plus 1, which is 3 times 4, which is 12, and there are 12 squares there. So we got the formula. Now we all see something different. Some people looked at like stage 2, and they saw a 2 by 2 grid plus 2. And then here they saw a 3 by 3 grid plus 3. So their formula would look a little bit different. So somebody else that wrote to me said they saw an n by n grid, which is n squared, plus an extra n at the top. So that's an alternate formula that works here, depending on if you saw it slightly differently. Okay. So that was a tricky one. Because this formula has a square or an n times an n, just note this is a quadratic pattern. It is not linear. And I'm just going to graph this quick on the next page to show that. So let's see, it's what? 2 and then 6 and then 12. So next page, oops. Did I do my lesson out of order? Apparently I did. Okay. Fix that later. So I'm going to try and graph the numbers we just generated. And the numbers we just generated, I'm going to use X and Y, because usually we say this is X and that's Y there. 1 had a 2, and the second stage was 6, and the third stage was 12. So let me see if we go 2, 4, 6, 8, 10, and then 12 would be way up here. And then scaling similarly over here. Actually, I'm going to scale this one different. I'm going to go 1 there, 2 there, and 3 there. When you graph, once you place that first number, you just got to make sure they're the same distance after that. So it's okay I scaled these slightly different, as long as I'm consistent on a particular axis. So then I am going to have the point 1, 2, which is right there. I'm going to have the point 2, 2, 6, which would be right there, and 3, 12, which is right there. And I just want to show that these suckers don't line up. Like the line from those two doesn't hit that one, right? So these aren't going to line up. The next one would be what? 4 times 5 is 20, which is off my grid here, right? So that would be 14. I better let's mark it out and see. Blue, 14, 16, 18, 20 would be just up above here. So somewhere around the S for backgrounds is where the next point would be, which doesn't line up with the other 3 points. So this is a curving pattern. And if we did, by the way, let n equal 0, just for fun, n squared plus n is my formula. If n equals 0, then I get 0 squared plus 0, which is 0. So even though that kind of doesn't make sense for squares, there would be a point here, and notice that doesn't line up with the others either, right? So all of these points line up in pairs, but they do not make a straight line. They make a line. They make a curve called a parabola. All right, next, spreadsheet time. Woo! So it would be good if you could get out a spreadsheet right now, and I'm going to use Google Sheets. If you like Excel better, that's cool. It works the same way in each one. So to do that, I need to go to my Google Drive. I like to go to my Google Drive first. And I'm going to stop and start this recording because this is kind of a new topic.